Hello YouTube, welcome to my channel where I talk about engineering things, and today I will be talking about voltage dividers. So I did this video yesterday and I thought, oh, this is such a great video, I'm gonna upload it. And then I watched it again today, 24 hours later, and then I realized, oh my gosh, I forgot some stuff and I drew some stuff differently, and I thought, I should just do it again. I should do a better job because you guys deserve better. Anyway, so here we are talking about voltage dividers again, if you've already seen the last one. So a voltage divider, also known as a potential divider, basically takes a big voltage and brings it down to a smaller voltage. How does it do that? Well, first off, I'm going to point out that I'm in DC because I do not want to deal with impedance. If you start introducing AC with inductors and capacitors, it gets pretty crazy, and I don't feel like dealing with that at the moment, maybe in another video. But for now, just DC. And I only have 2 resistors, no load, just 2 resistors in series. And in future videos, I will do a few more examples of some other voltage divider circuits that have loads or have more resistors. Anyway, let's start by saying to solve for V out, if you only are given V in and R1 and R2, I need Ohm's Law, which states that voltage equals current times resistance, and Kirchhoff's voltage law, also known as KVL, which states that the sum of all voltages in a circuit should equal 0. So what does that mean? It means that the voltage here should be V in, and by the time it gets to here, we don't know what voltage this node has over here, but we do know that by the time it gets to here, it should be 0. Okay, and also this is a series circuit, so the current in the loop is the same, it's constant. So that means current here is the same, and the current over here is the same. That really helps us, because now we know that the voltage drop here is equivalent to V out. So according to Ohm's law, V out equals I times R2. Now you might be thinking, oh no, Jirachi, you gave me another variable that I have to solve for? Well, no, if we keep going, we'll see that the i's will cancel. So let's do that, let's keep going. Now let's look over here at V in. We know that V in also equals to IR, but what's R? We have 2 resistors over here. Which one of these is the R? Well, let's draw the equivalent circuit over here. And we have one big R over here. Now, what is big R? Big R is the equivalent of R1 plus R2. Because these resistors are in series, we can simply add them together to get the big R. So R1 plus R2 equals R. Now let's plug that in. I times R1 plus R2. Alright, we have V in and we have V out. Are we done yet? No, we still have to figure out what this I is over here. So remember how I said this I is the same as this I over here? That means we can solve for any one of these in terms of I. And let's use this one. This one's easier. I equals V out over R2. Now let's take this I and plug it in over here. We have V in equals V out, sorry for the messy handwriting, over R2 times R1 plus R2. Now this is great, but we could simplify this. We can isolate V out, and we can solve for V out. Yeah, it equals V in times R2 over R1 plus R2. And here, folks, we have the voltage divider formula for two resistors. Yay! Okay, so let's plug in some values and see what happens. Let's say we have V in equals 20 volts. And let's say we have R1 equals 1k ohms, and R2 equals 1k ohms. Okay, these are some pretty common values. Let's start plugging them in and see what happens. V out equals V in, which is 20 volts, times R2, which is 1k ohm, over R1, which is 1k ohm, plus R2, which is 1k ohm. Sorry, never forget your units, folks, because units save lives. Okay, and this is, okay, after everything cancels, 20 volts times 1 over 2 equals 10 volts. Now, if you notice, the equivalent resistance means that V out will be half of V in. So it could be 3K and 3K, it could be 5K and 5K, it doesn't matter, it'll always be half, ideally. Now, Jarachi, what happens if I have two different resistor values? What if this is 2K ohms, and what if this is 8K ohms? These are completely different values. Well, let's plug them in and find out. V out equals 20 volts over R2, which is 8K ohms, over R1, which is 2K ohms, plus R2, which is 8K ohms, and then that equals 20 volts over, what is that, 8 over 10, that's 4 over 5, equals 80 volts over 5, which equals 16 volts. Now I want you to see that this is V out. So V out over V in was 16 volts over 20 volts, which when you do some cancellations, that equals 4 over 5. Whoa, does that ratio look familiar? It's this ratio, it's that same ratio over here. So it took me a long time to realize this, but all this math proves is that V out is equivalent to V in times the ratio of whatever you're trying to get the V out of the resistance over the total resistance. Whoa, that took me a while. Some people were very insightful, didn't even need the math, they just couldn't kind of figure it out. But yeah, so sometimes you need the math to prove it to you, and here it is. Okay, so my next video, like I said, will have more examples of voltage dividers. What if there's 3 or 4? Or what if you have an extra load in there? We'll find out in my next video. And hopefully after that video, I'll give you guys some examples of real-life voltage dividers and how you can use them in everyday life. So if you have any questions, comments, or concerns, please comment in the video or comment in the comment section below. Thank you.